So here we are at the Math 2 Unit 11 test review. First thing we need to do on problems 1 and 2 is to simplify down the expression that we have. So this is multiplication, so we're going to go 10 times negative 2 is negative 20. We have x to the fourth and x to the third. Now it's not like a combined like terms, these are multiplying together, so we add the exponents and we get x to the seventh. Y and y to the second gives us y to the third. In the next problem, number 2, we get a negative 12 from 6 to negative 2. X to the fifth and y squared because we combine the exponents. In number 3, it says to simplify, we're adding two polynomials. This is really combining like terms. I have a 4x squared and a 5x squared, so that's 9x squared. 9x and 2x gives me 11x, and then a negative 1 is my final term. Similar to that, number 4, we're going to combine like terms again, but we have to be careful because it's minus this. So it's going to be minus a 6x to the third minus a 2y, and that's distributing in the negative to each term. So now it's 4x to the third minus 6x to the third gives me negative 2x to the third, and 9y minus 2y is 7y. For number 5, combining like terms again, I have 5 and 5, so that's going to be 10, and it's going to be x to the third because you leave the exponent the same. X to the third, it's saying how many we have. 5 and 5 gives us 10. For number 6, I'm going to rewrite this after I distribute the negative, so that's minus a negative 2y squared is plus 2y squared, plus 8y, and minus 7. So now I look at my like terms. I have a 9y to the third, and that's the only one, so we got there. That's gone. 2y squared is my only y squared. That one's taken care of. Y and 8y give me 9y. Those two are taken care of. And then negative 1 and negative 7 is negative 8. For number 7, the perimeter of the pentagon is 14x plus 9. We have 3 sides. We need to find what else would work. So my 3 sides, 4x, 3x minus 2, and x plus 5, add up to be 8x plus 3. And I need to get 14x plus 9. So I'm going to subtract this 8x plus 3 to find out what I have left over. And when I do that, 14x minus 8x is 6x, and 9 minus 3 is 6. This is what the 2 remaining sides have to add up to be. So now I look at which one of these meet that condition. So 5x plus x plus 6 is 6x plus 6. So these two would work in that combination. The B answer gives me 6x minus 6, which does not match because it's plus 6, not minus 6. Here I get 6x plus, that's 7 minus 1, 6. That would also work. And then D, we get 6x plus 6 after we combine, so that works. So all 3 of those answers, A, C, and D, work for it. So then we do the same idea on number 8. We have a hexagon, and we need to find the pairs that could work. I have 8x, 3x minus 2, x plus 3, and 2x minus 3. So that looks like it comes out to be a 14x minus 2. So I'm going to subtract 14x minus 2 from 18x plus 5. And that leaves me with 18x minus 14x is 4x. 5 minus a negative 2 is the same as 5 plus 2, so that's a 7. So which one of these are going to be 4x plus 7? So here I have 5x plus 7, that's out. 4x plus 7 here, so that works. This becomes 6x plus 7, that's out. And then the last one we have 4x, and then 17 and negative 10 is positive 7, so that one works. So B and D are the answers. For number 9, choose all the expressions that are equivalent to the following, even if they're not factored completely. So let's kind of look at this for factoring and then look what the other ones are and see if we can make some progress. So I could factor out an x from this, and actually a 3x. And I'm left with 4x squared minus 4x plus 1. And now I can look to see what's matching, what's not. Well, this is a possibility, 2x minus 1 squared. If I did 2x minus 1 times 2x minus 1, it comes out to be 4x squared minus 2x, and 1, which gives me 3x times 4x squared minus 4x plus 1. And that does match. So we know we're good there. What's not going to match is this one, 3x times 2x plus 1 squared, because now that's the plus instead of the minus. These would actually become a 4x. So this would be 3x times 4x squared plus 4x plus 1, which does not match. So that's out. If you need to multiply it out to check, you can do so. Let's look at answer D. Well, that matches exactly, so we know that one works. Answer C is a difference of two squares. 2x minus 1 and 2x plus 1 become 4x squared minus 1. So that's going to be out. And the last one we have E, and that's our fraction. So I'm going to multiply the 1/3 x into each of these and see if it comes out to be that. Now the x's I know comes in, it's going to be x to the third, x squared, and x. But what's 1/3? So 1/3 of 36 is 9. No, that'd be 9, that'd be 12. 1/3 of negative 36 is negative 12, and 1/3 of 9 is 3. And this actually comes out to match, so that will be our other answer. A, D, and E. For number 10, we're going to multiply and simplify. So I get 3 and negative 5 is negative 15. We get x to the fourth, y squared when we combine exponents. Number 11 is like saying x minus 6 times x minus 6. We can draw the box out to multiply. I get x squared minus 6x and 36. So our answer is x squared minus 12x plus 36. Number 12 is the same idea. We're going to multiply the two out, write them separately. So that's 2x minus 3 times 2x minus 3. We got 4x squared minus 6x, and positive 9. So that's 4x squared minus 12x plus 9. For number 13, we're going to do x plus 3y and x plus 3y in the box. I get x squared, 3xy, 3xy, and 9y squared, which with like terms, this becomes a 6xy and a 9y squared. So x squared plus 6xy plus 9y squared. 14, we go x plus 3, x minus 1, we got x squared, 3x, negative x, and negative 3. So it becomes an x squared, 3x minus x is a 2x, and then minus 3. Number 15, we have 4x plus 5 and 2x minus 7. This becomes 8x squared plus 10x. Then we have a negative 28x and a negative 35. Our terms become 8x squared, that one stays. 10 and negative 28 is negative 18x, and then negative 35. 16, we have a trinomial times a binomial, which is going to work the same way for the box. We're just going to have 3 columns instead of 2. Be careful in the exponents as we go through. We have 8x to the third minus 54x squared minus 18x, then negative 12x squared, be 81x and 27. So our first term is 8x to the third. Then we have negative 54 and negative 12, which is negative 66x squared. 81 minus 18 is 63, so 63x, and then plus 27. 17 will follow the same pattern. I'm just going to break the box off of the first term and write 5x minus 1. We get 15x to the third, 10x squared, minus 20x, negative 3x squared, minus 2x, and 4. So 15x to the third plus 7x squared minus 22x plus 4 is what we get when I combine my like terms. Now for 18 and 19, I need to write the expression in equivalent binomials. This is saying I'm going to factor. So y squared minus 49 is our difference of two squares. You could also think of this as y squared plus 0y minus 49. And what is going to multiply to negative 49 that adds to 0? Well, the only ones that are going to work are going to be negative 7 and positive 7. So that becomes y minus 7, y plus 7. Now 19 is the same idea, but now we have a coefficient in front of the x squared. And really it's looking at these square roots, because this is 4x squared and this is 5y squared. So it becomes 4x minus 5y, 4x plus 5y, using our difference of two squares rule. For number 20, we're going to factor. So I look at 8x to the third plus 3x squared. I can take out an x squared from each term. This leaves me with 8x plus 3. There's no more common factors, so we stop there. Number 21, I had 10 and 15. I can take out a 5. I have an x squared and an x to the third. I can take out an x squared. And y squared, I can take out a y. So this leaves me with here dividing 10x squared y by 5x squared y, which is to 2. 15x cubed y squared, when divided by the 5x squared y, becomes a 3 with an extra x and an extra y. So we get this result. 15x squared y times 2 minus 3xy. Number 22, I have 15 and 60 I can divide a 15 out of. X and x squared, I can take an x. Y to the fourth and y to the third, I can take a y to the third. So in dividing, out of this, I have all I left with is a y. And out of 60x squared y to the third, I have a 4 and an x. For number 23, 9 and 33, I can take a 3 from. I can take 4 v's and 3 w's. So this leaves me with 3 v squared and then 11. V is gone, we have w squared. Now we get to our factoring trinomials. So this is where we're going to look at multiplying, adding, and find the sets of numbers that work. I need to multiply to negative 32 that adds to negative 4. So if I'm thinking of 32 and I want to add to negative 4, it's got to be negative, so one's positive, one's a negative. So I almost have to be 4 apart from each other when I look at the two numbers. So like 32 is 1 and 32, 2 and 16, 3 and, no, 3 doesn't work, 4 and 8, 5 doesn't work, 6 doesn't work, 7 doesn't work, 8 doesn't work. So these are the factors we're going to look at. Now which one of these are 4 apart? Well, 4 and 8 are 4 apart. But I want it to be a negative 32, so one has to be negative, but they have to add to negative 4. So if I go like this and say negative 8 and positive 4, it would meet that condition. Why did I write multiply? It needs to add. Okay, so it becomes 4 and negative 8, so that's m plus 4, m minus 8. And those are my factors. Okay, now we go to number 25. Same idea. We have to multiply to 72, negative 72, that adds to 21. 72 is 1 and 72, 2 and 36, 3 and 24, 4 we could divide and get 18, 5 wouldn't work, 6 would work, that's 6 and 12, 7 wouldn't, 8 would be 8 and 9, so we have this big long list. Now, one has to be negative to get a negative product, but the bigger one needs to be positive and they need to be 21 apart. So I'm looking at 3 and 24 look nice, because if it was negative 3 and positive 24, we would go d minus 3, d plus 24 as our factors. And remember, your backup, your way to check your answer on any of these problems is to do the box method, multiply back, and go to an answer, kind of like what we did on problems 13 through 17. 26, we want to multiply to 60, that adds to 19. I'm looking at 4 and 15, so we go w plus 4, w plus 15. Number 27, with 63, if we go 9 and 7, that adds to 16, so x plus 9, x plus 7. Number 28, we have common factors, so we can actually divide out a 2, which leaves me with 2n squared plus 31n minus 16. Then I multiply the first and last term, so now it needs to multiply to be negative 32 and add to 31. Well, if they have to be a negative but a positive sum, I could go negative 32 and positive 1, but wait, that'd be a negative. Let's switch that, make it negative 1, positive 32, it would work. So now, kind of ignoring the 2 to the end, we'll kind of bring it down. I'm going to go 2n squared, break apart the 31n to be 32n minus n minus 16. So it's been split to these two numbers. Now I factor the first two, factor the last two. 2n comes out, I'm left with n plus 16. Negative 1 comes out, I'm left with n plus 16. So these match, that's one factor. Then the leftovers, 2n minus 1, is the other. Not forgetting the 2 from the beginning, we have our answer. Now, number 29 works the same way. We go 5 and 14 is 70, so we're going to multiply to that, add to negative 17. Well, negative 7 positive negative 10 would work, so let's go 5z squared minus 7z minus 10z plus 14. I can take out a z, and I'm left with 5z minus 7. I could take out a negative 2, and that gives me with 5z minus 7. And these should match. If they don't, you need to go back and fix them. So they match. We're good. So we got 5z minus 7 and z minus 2. Number 30, we multiply. 2 and 15 is 30, and it needs to add to 13. I'm thinking 10 and 3. So we'll go 2w squared plus 3w plus 10w plus 15. I can factor out a w, which leaves me with 2w plus 3. I can factor out a 5, leaves me with 2w plus 3. Take the matching, that's 1. Leftovers are the other, w plus 5. Now 31 we can think of as 4a squared minus 0a minus 25, and think of multiplying to negative 100 and breaking it apart, but it's also the difference of two squares. And so that's going to be this term squared minus this term squared. We go these square roots, which are 2a minus 5, 2a plus 5. Now that's the quick pattern to it. Now let's solve it if it wasn't, just to make sure we get to the same answer. So this 4 times negative 25 is negative 100, and it has to add to 0. So negative 10, positive 10, leaves me 4a squared minus 10a plus 10a minus 25. If I factor out a 2a, I'm left with 2a minus 5. If I factor out a 5, I'm left with 2a minus 5. So the 2a minus 5 is our first factor, and then the leftovers, 2a plus 5 are our other. It still gets there. Either one works. If you want to go stick to the regular method, just put a 0a in, and it'll get you there. 32 is the same idea. We have the square roots. Instead of doing the long method, it's going to become 5x minus 12, 5x plus 12. 33, I'm going to do 7 times 9 is negative 63, and it needs to add to be negative 2. Well, 63, I think of 9 and 7 immediately. If the negative, one's going to be negative, the bigger one's negative, so that's negative 9. So we're going to go 7c squared plus 7c minus 9c minus 9. We take out a 7c, and I'm left with c plus 1. We take it out negative 9, I'm left with c plus 1. We get c plus 1, 7c minus 9. For number 34, we need to select the expression that's equivalent to this one. And if we look before multiplying out, both of them have an x plus 3. This one happens to have 2 of them. So if I take one out, that's one left. And then this, getting rid of the x plus 3, all it's left with is the x minus 6, which is the answer we want there. So it's not multiplying out and solving it, it's just kind of looking at getting the factors. For number 35, we need to write the expression equivalent after we factor out a GCF. So I notice I have an x minus 5 in both of these. So if I took out an x minus 5, I'm left with, in this term, just an x minus 5. And in this term, it's minus x plus 2. So that's what I get when I factor it out. Now if you don't see that, if I wrote something like a squared minus ab, I could factor out an a and be left with a minus b. It works the same way here, but instead of just talking about single variables, we have binomials. For 36 and 37, you need to figure out the number that goes in the box. Now here, I don't even necessarily have to multiply these all out. Let's start with these getting 15x plus 6, and then the 4x plus 1. Now, in multiplying the box method, these extreme values are going to be the first one, 60x squared, and the last one, which is 1 times 6, which is 6. Because these other ones, 24x and 15x, are what becomes the 39. So it's really doing 3 times 5 times 4, which is 60, and 3 times 2 times 1, which is 6 to get those values. Now if you don't see that, then go through, just multiply it all out, and make sure you get the matching values. 37 is going to work the same way. I'm going to multiply in the 2 and get 6x minus 2 times 2x plus 7. I know I did this one correct when I have a negative 14 at the end. Oops, that should be a 7. So we get 12x squared, 42x, minus 4x, minus 14. There's that minus 14, that's a good sign. First number is 12x squared, and then I had 42 minus 4 is 38x. For number 38, we have a square with side length of 4x minus 3. To find the area of a square, we multiply the side length by itself, or it's 4x minus 3 squared. If we come to that, we are not going to distribute in the square. That is not how it works. It's saying we have 4x minus 3 times 4x minus 3. So 4x minus 3, 4x minus 3, we get 16x squared minus 12x plus 9. That's 16x squared. Negative 12 is negative 24x, and then plus 9. 39 is the same idea. We're just going to multiply 3x minus 1 and 4x plus 3 because it is looking for area of a rectangle. So we get 12x squared minus 4x, 9x, and negative 3. 9x and negative 4x gives me a 5x and a negative 3, so we get 12x squared plus 5x minus 3. For 40 and 41, we need to factor down to find the possible dimensions. Really, it's saying we have 3 factors we can get out of either of these. So if I had x to the third plus x squared minus 6x, the first thing I'm going to take out is an x. So I'm left here with x times x squared plus x minus 6. Now I need to factor this. So what is going to multiply to negative 6 that adds to 1? Well, negative 6, I know one's positive, one's negative. So maybe like 2 and 3, I know gives me 6. If the 2 is negative, then they add to 1. So this is going to be x times x minus 2, x plus 3. And those are my 3 factors, which would be possible dimensions. Now that same idea goes to number 41. What can we factor out? All of those are even, so I can take a 2 as well as an x. So I get 3x squared minus x minus 10. This one is going to be the factoring where I take the first and last term and see that I'm multiplying to get a negative 30, and they have to add to be negative 1. Well, negative product, negative sum means the negative number, let's go with like 6 and 5. With the 6 being negative, that adds to be negative 1, multiplies to negative 30. So we're going to go 3x squared minus 6x plus 5x minus 10. Factor out the 3x, we get x plus 2. Or I'm sorry, x minus 2. Factor out a 5, we get x minus 2. The x minus 2's match. 3x plus 5 is what's left. Bring down the 2x, and then here are 3 factors that make up the prism. For 42, we have a square stained glass window. Length of the window is 40y. The area of the circle inside is 100 pi y squared. Now the area of this square is going to be 40y, that quantity squared, because it's the side length squared, which comes out to be 1600 y squared. and then minus the area of the circle, which is 100 pi y squared. Now, it doesn't want us to find what the value is to a decimal. We just need to be able to factor it down. So in both of these, I can take out a 100, as well as a y squared. So if I took out a 100 from 1600, that leaves me with 16. The y squared and y squared are gone, so it's just 16. If I took out a 100 and a 100, that's gone. Pi's still there, and the y squared is gone as well. This is the factored form of this problem. So you need to be able to get to this and then write the factor. Now for 43, a square area rug has a circular design in it. The length of the rug is 15y, and the circle is 85 pi y squared. Very similar to the previous problem. So we're going to go 15y, and that quantity is squared, to be 225y squared, minus the area of the circle, 85 pi y squared. And what can we take out? Well, I know y squared is coming out. Let's look at 5. If we divide out of 5, 225 divided by 5 is 45. And 85 divided by 5 is 17. So after dividing that out, we have 5y squared times 45 minus 17 pi. That's our factored form. We're going to leave it as that. Okay, now in these last couple problems, we have to find the first mistake as we look through and correct the mistake that we see. So first up, I have, it looks like x minus 5, x plus 1. I multiplied those two, and that came out to be a 4x and a negative 5, which, if we look, x times x is x squared, x times 1 is x, negative 5 times x is negative 5x, and then negative 5 times 1 is there. But right here, doesn't x and negative 5x combine to be a negative 4? So our first step that the mistake is in is step 2. And what that should be is x squared minus 4x minus 5 times x minus 2 squared. Now, just for the sake of it, we can keep looking. It looks like on the next step, they split these two, x minus 2 squared, into the here. This then multiplies out to be pretty good. We have our lots of steps in multiplying. If you want to use the box here, you'd have the same values, and it looks like it follows through, but step 2 seemed to be the problem. And it's something as easy as missing that negative 5x and x actually come out to be a negative 4x instead of a positive. 45 is going to work the same way. First step, we did x times x and got x squared. We did x times negative 2, negative 2x. Negative 1 times x, negative 1x. And negative 1 and negative 2 is positive 2. So we're good there. Next step, they took the negative 2 and negative 1 and wrote negative 3. So we're good there. Now in this step, this one stayed the same. But now x plus 1 squared is x squared plus 1. And that is wrong. X plus 1 squared is not x squared plus 1. So step 3 is the issue. X plus 1 squared is x plus 1 times x plus 1, which comes out to be x squared plus 2x plus 1. So what it should look like is this instead of x squared plus 1. So it's x squared plus 2x plus 1. Okay, the last one, our challenge problem. Let's look at what we have here. This is a difference of two squares. So it actually becomes x squared minus 4, x squared plus 4, which this is still a difference of two squares. And we could split that and make it x minus 2, x plus 2. What we can't do is split this one up because it's not a subtraction. There is no way that we can get an x squared plus a 4. That's not going to work. So we just keep it through. We get to that. But anywhere that you see a squared minus b squared in that form, you can write it as a minus b, a plus b, and it starts to repeat itself. And that allows us to really factor twice to get our answer.